Hello and welcome back to the first day of the 5th International Conference on Natural Resources and Sustainable Environmental Management. In the first session, we are hosting Professor Dr. Zekâi, Professor Dr. RAOUDHA GAFREJ, Professor Dr. BARIŞ SALIHOİOğlu, and Professor Dr. Mehmet Karaca. Welcome, professors, and thank you for joining today's session. Firstly, as the first speaker, I would like to invite Professor Dr. Mehmet Karaca to deliver the first presentation of the conference.
Good afternoon, all. I'd like to thank to all the organizing committee, and particularly Professor Dr. Hüseyin Gökçekuş. And let's have my slides. Actually, I'm going to talk from the global scale to regional scale. I cannot see my slides. Okay, my talk is on global climate change, just briefly, very brief, and its reflection on the Eastern Mediterranean. And next slide. Can we see the next one?
Is this a slide, Professor?
No, the next one, the second one. It's stuck, it seems to be.
Professor, which slide are we talking about?
Second one. Next. Second one. No, you went. Oh, yeah, this one. No, always be confused about the climate and weather. Climate is what you expect, and weather is what you get actually. The climate, in the physics, we talk about the envelope of probabilities, but Earth system itself is. It's an initial value and boundary value problem. What you get at the beginning and then when you simulate, but it's also affected by the boundary values. Let's talk about next one. Went to first title. Can you make the full screen? You went far. The previous one. Yeah.
Professor, yes, we're at slide number 3 now.
Yeah. The mean values of the climate is kind of sources for agriculture, forestry, and tourism, transportation, for city settlements also. For example, the climate of Central Anatolia, it's a source for wheat production, actually. But when we have variability, is uncertainty and risk all starts. But when it starts changing in the climate and threat, when you expect the extreme events, values such as long events like droughts and floods, it's a disaster actually. We can see the climate starts from source to disasters. Let's continue. When you talk about the disasters, previous slide, you went far. Fourth slide, please. Yeah, this one. Disasters on natural disasters, almost 90% of the disasters related to weather, water, and climate. For example, floods takes a lot of place, in almost 37% to 40%. Heat waves is 5%, but only small portion is related to earthquakes. It's only 8%. In comparison to climate and water and weather disasters. Let's continue. Next slide. When you talk about the climate and variability and change, there is a natural variability in the left-hand side. The natural variability, long is the story, is related to tectonic movements of weather, and also the position of the Earth is related to sun. For example, the Milankovitch cycles every 20 years, every 40,000 years, and every 100,000 years, exactly, not exactly, it's approximately, it's you face the glacial years, such as 10 years ago, 10,000 years ago, we were in the Holocene cycle. It was a glacial year, but this time we are in the warming position according to natural variability. But when you talk about the man-made change, which is the climate change we are talking these days, it's affected by the greenhouse gases and aerosols because of the greenhouse gas, the carbon dioxide. Of course, the water vapor is also a greenhouse gas, but it's not stays longer than a few days in the atmosphere. Therefore, it's not dangerous like in comparison to other greenhouse gases like carbon dioxide and argon and methane, because they stays longer than 100,000 years, actually 100 years. Then when we talk about the man-made change, also we try to change the land cover and land use change because of the agriculture and land use and building up cities. That's also creates the man-made change in the climate. Next slides. Everybody familiar with the instrumental records in the last 200 years, starting from the Industrial Revolution. These are the long-term temperature based upon the anomaly, actually, based upon the mean value. We can see in comparison to 1900, actually 20th century's values, it's almost 1 degree, 1.2 degree actually these days. We are facing the global picture, global temperatures rising. Next one. If we separate the land and ocean temperatures from the 19th centuries, 1860s, you see at the beginning, this is actually not observed. Most of them is computed by different methods. Up to the 1980s, you see the ocean temperatures and land average, sea surface temperatures and air temperatures coincides together. But after 1980s, ocean average is a little bit lower because of its natural structure because of the liquid, but the air temperatures is rising, as you can see, land average actually. Next slide. When you talk about the regional scale, the green line is global picture of the temperature anomaly, but the blue line is Mediterranean basin picture. If you see up to the 1980s, up to actually it's 90s, is the Mediterranean air temperature. It's almost coincides the global temperatures, but after these years, last 20 or 30 years, the air temperature is increasing rapidly than the global value in the Mediterranean basin. Let's see the next picture. When you talk about the simulations, it says that, we have 4 different scenarios. Worst scenarios to best scenarios, green scenarios, 4 different scenarios according to worst case scenarios. If you see the differences between 1940 to 60 average values minus 86 to 2005, it's in temperature anomaly. You see in global, in the northern hemisphere, in the North Pole, it's up to the 5 degrees. It's increasing in the worst case scenario. In the Mediterranean basin, if you capture from the picture, it's very small, but 2 to 3 degrees we can expect it according to worst case scenario. But in the precipitation, that's bad values we're gonna face it. 10 to 20% decrease in the Mediterranean basin in the precipitation. Next picture. When we talk about the best case, actually the best scenario again versus to worst case scenario, RCP 2.6 is a good scenario. We are gonna keep all the greenhouse gas as usual in the lowering in the green scenario, as I said. But the worst case scenario is according to worst case scenario, we can face this 3 to 4 degrees increase in the Mediterranean basin and almost 20 to 30% decrease in the precipitation. In the best case scenario, it's a little bit increase in the 10% in the precipitation, but in the temperature, it's up to the 0.5 to 1 degrees increase in the Mediterranean basin. Next picture. When we talk about the global sea level changes, in the worst case scenario, RCP 3 actually, I cannot see actually. Can you make it bigger? Yeah, 8.5 case scenario is the global sea level. It's going to be increased in the up to the 1 meter, but in the best case scenario, it's 20 centimeters. Let's continue. For example, when we look at the anomaly differences, February months in 2018 to average value 1980 to 2017, you see the Eastern Mediterranean will face really great numbers of increase in the air temperatures up to the 4 degrees centigrades. Really, you know, this area we are living on, Eastern Mediterranean, it's really it's a vulnerable region, I can see from this picture also. Next picture. When we talk about the global sea level, I'm not going to go in detail. There is, of course, thermal expansion due to the melting the glaciers and ice sheet on the seas and oceans. And plus, also, when you added these waters, you see the 8 centimeters is really increasing in up to the 2019. Next picture. When you talk about the coastal risk index, really is Mediterranean region is really extremely high values, have extremely high values related to coastal risk index, especially some parts of the Cyprus and Adana, Mersin, Antalya. It's really in the high risk because of the this all cultivated agricultural land is in the danger. Starting from the Italy to Eastern Mediterranean, especially in the Middle Eastern countries, North African countries, are in the deep problem. Next picture. If I talk about the Turkey, you know, in comparison to global pictures, also in Turkey, the values in the temperature is also increasing. Next picture, especially in summertime. But for the precipitation is unpredictable, as you know, because you cannot see in the Gaussian distribution. It's really unpredictable. But you can see the average values in general in Turkey. It's fluctuating seasonal to seasonal, but in the southern Turkey, it's decreasing in last 100 years. But in the northern part of the Turkey, it's also increasing. Very slight numbers. Next picture. But how we explain this mechanism? As you see in the right-hand side in the up, there is a mass transfer of the atmospheric circulation. There is a Hadley cell from equator to 30 degree northern latitudes, And also there is a Ferrel cell, is a little bit smaller than the Hadley cell, but in the small portion of the small cell is a polar cell. But Hadley cell is as a summer and winter fluctuations. In the summer, it goes to the descending motion of the Hadley cell. You see all the 30-degree northern latitudes. All the deserts are located in, like Sahara, Arabian, Taklamakan, and northern United States also, no, southern United States. But this descending motion, dry and warm air is descending here. But in summer, it shifts north and creates long summers and dry summers in the Mediterranean climate. But in this winter time, it goes towards the equatorial region. It shrinks and brings in the northern part, brings all the rain. Next, let's talk about the next slide. This one. If you talk about the Hadley cell, and I don't know, can you see my cursor? It's difficult, probably. You know, the Hadley cell is, if it goes north, which we expected, it's going to expand in the northern part. And you see the Azor high pressure center will go in the north. And because of this storm track path, it's going to be northerly, and less rain and precipitation will come to eastern part of the Mediterranean region. At least 2 to 3 degrees north, the circulation will move, we expect, due to the climate change. Next slide. Therefore, according to the ice simulations for temperature and precipitation, which is not different than the other part of the eastern Mediterranean region, in southern parts, precipitation will reduce to up to 20 to 30%. But in the northern part of the Turkey, which is the high mountains regions, especially in the eastern part of the Black Sea region, and it will increase to 20 to 30%. But for the temperature-wise, temperatures are in the worst-case scenario. It will go to 3.5 to 4.5 degree in the southern part. In the northern part, 2.5 degree will be increase in the temperatures. Next slide. And this also shows if you look at the Cyprus and Lebanon and Syria and Greece also, there is a decrease in up to 30% in the precipitation, and in the northern part in Black Sea area, and increase in the precipitation in 30%. But these are average values. Next slide. This 9 pictures summarize all the worst-case scenarios, and reduction in the precipitation in the Eastern Mediterranean basin up to the 2070s and up to 2020, 100, and precipitation less than evaporation in the southern part, which is the Eastern Mediterranean basin. Of course, it will cause a reduction in the surface runoff, as you can see, in every 30 years. Next slide. These are mean values, but actually we have to talk about the extreme events. We already passed talking about the mean values, average values in the climate change. We have to talk about the consecutive dry days, for example, in this picture, and differences between 90, for example, in 61 to 90. When you expect the next 30 years, pictures in the winter times, in the southern part of in Turkey, also in Cyprus and the Middle East and Greece also. In winter, the number of the consecutive dry days will be increased. And in spring, the increase will be, it's going to be ascending also. It's going to be increased more. In summertime, we'll face more than consecutive dry days, as you can see. And summer is more disastrous. It really will create the drought, long-term drought days. Next slide. Talking about the wet days, above the 10 millimeter over, actually, and differences between 1961 to 90. You can see that in winter, the wet days will be reduced in the eastern basin of Mediterranean, in the up to this end of this century. In spring also, it will cover all the area, and the reduction in the wet days. And in summer, it's going to be it seems increased, but it's not valuable because we are gonna face less rain in summer than the winter and spring and fall also. This will crowd also create drought days. Next picture. Let me summarize in this graph water, food, energy, and climate connection. When you have the climate change in the middle, of course, we are going to face the warming and drought. And drought means reduction in the precipitation. It's going to cause the farming by rain is going to be reduced. And also irrigated farming reduce. And that means food supply will be reduced also. Water resources will be reduced because of the evaporation will be increased. And when you have the evaporation increase, water resources is going to be reduced. And water supply also reduced. Of course, it will not only create problems in the agriculture, also it will create the supply in the hydraulic energy generation. That means energy supply will be decreased. When you talk about the population growth, also it's a problem, financial boost, and water demand also, because of it create the water demand stress, and food demand also will be increased, energy demand increase. Of course, agriculture and also the husbandry, which is production of animals, also it will be increased. The demand will be increased. A generation of energy also coming from the fossil fuels will be increased. And it will create also climate change, and also heating and heat waves. It will be increased in terms of because of the climate change, and also the need heating in the winter, and need cooling also in summer, and of course energy demand will be increased, and that will create problems and problems. It will continue like this. This is the graph explains stress coming from the population growth and also the stress coming from the climate change. Next slide, please. And now, please touch, and I can see the results. I can show the results. Climate change, of course, will be reduced to precipitation and due to the increase in temperature, especially, for example, reduction in the snow cover and depth of the snow cover also will be is decreasing, especially I'm going to talk about the Euphrates and Tigris rivers, and also it will create the problems in water supply to Syria and Iraq also. And when we expect 10 to, I already said in the heavy rainfall increase in the 10 to 20%, and it's already in sea surface temperatures increasing 0.4 degree. And of course, the problem is pH in the seawater is also decreasing. That will create the problem in the oceans. It takes the most of the greenhouse gases also. Therefore, decreasing the water resources, it will create the water stress. Low-lying coastal agricultural land and cultural sites, especially in Turkey and Greece and also Egypt and Lebanon, will create problems such as Ephesus, Miletus, and those places also will be. For example, Ephesus and Miletus, it used to be a coastal region in thousands years ago. And also we are expecting at least 20 million people will be migrated due to the climate change. We are expecting up to the 2100 up to this century. Less agriculture that creates food security, of course, and it will decrease in the hydroelectric power. And also sea floods, especially, will be increased. And the economic values, they are expecting 150 to 900 millions in up to the euros in 2100 years. And water resources, especially in Tigris and Euphrates, Aras and Çoru rivers, it will create the water resources nationalism, actually. And some of the speakers at the beginning explains already. And that's, we can see the depth of the snow cover in the eastern Anatolian plains also decreasing. And what we can do, adaptation, mitigation, everybody talk, especially in the Glasgow. Of course, saving waters, changing the lifestyle, and saving also lives also. And that's all I think. People are talking about this geoengineering solutions. None of them will work, especially, for example, the aerosols in stratosphere. It's proposed by the Paul Crutzen, who got a Nobel Prize in chemistry. But he died at the beginning of this year, actually. But the cloud seeding is also, it's a dream, actually, to me. But its duty is for us, actually, for human beings, saving everything and the friendly environment also. And that's all I can say in this short time. Thank you very much indeed.
Thank you, Professor Karaca, for your valuable presentation. I would like to take questions later at the end of the session. Do you agree, professors? Is it fine to take questions in the end?
That's okay with me. If they have it, short questions, short answers.
Okay. Short questions if we have any questions to Professor Dr. Mehmet Karaca. Professor, I guess we don't have questions at this time. If there are any questions, then we may be taking questions later.
Thank you.
Okay. Thank you very much for your speech, Professor. Okay. Next presentation, I would like to invite RAOUDHA GAFREJ to deliver her presentation. Professor RAOUDHA?
Yes, good morning everybody, and thank you for your invitation, and thank you for all organizers of this important conference. Thank you for Professor Mohammed Karaca for his introduction, very useful, and it makes me more comfortable to present, so I am not going to go through some evidence that he presented in his presentation. For today, I'm going to present a new approach for valuing water under climate change opportunities. You know that, as Professor Karaca says, when we speak about climate change, of course, there is a loss or a reduction of precipitation and water resource, but in many cases we have an intensification of extreme events that mean drought and floods. And instead of speaking about floods, we are speaking about opportunity. It means we will have in many cases or many times floods. Instead of speaking about floods, we will speak about too much water and how to evaluate this water. So climate change adaptation, I'm going to present an adaptation and climate change adaptation project to secure water supply for coastal and inland cities in Tunisia. But first of all, I want to present you the situation in Tunisia. Maybe you know the scarcity, the water scarcity situation in Tunisia, as you see by these two indicators. The evolution of water stress indicator is very high, more than 100%. The indicator 6.4.2, the water stress indicator. So we are in very, very, as I say, bad situation. And if you look to the second graph, so we'll see that from 1990 to now, all investment that the government have put in place didn't change the situation of the water resource allocation. It means we are under 500 cubic meter per year per capita, so we are in very extreme water scarcity situation. This means that even if we can save water, changing pipes, increasing the efficiency of water use, etc., we can't have more than this quantity of water. It means we still have in the future less than 5 cubic meter per day per capita. So we need a new approach, we need a new technology, a new way of thinking how to get more water. Of course, we can make desalination. I will speak about that later, but there is other situation. With this situation, bad situation in terms of water availability, we have the climate change, which bring a new constraint on water resource and on their uses. That means agriculture, irrigated area, and water supply for people. Climate change in Tunisia, the projections say that we will have by 2050 something like 2.8 degree using the RCP 8.5 and less, and something like 14% less in precipitation. And if you look to the graph on my left, you will see that these 10 last years, we have faced 5 drought period, 2016, 2017, 18, and 2020 and 21, and we are going in the 6th. This year is a drought year also. That means that from the period 2012 to 2021, we have 5 drought years. Last 10 years, from 2002 to 2012, we have got only 3 drought years. That means that in the future, we can't make any planification of water using the medium or the average of the situation. We are facing a situation where we have to think about development using thinking only in case of extreme events. It means especially drought and floods. Of course, for example, in 2012 we have got a very, very important year in terms of water availability. The next issue about the future is the increase of population and the increase of water supply, the need of water for people. If we can see in this picture, by 2030 we will need more than 1,000 million of cubic meter only for water supply. It means for potable water, and we can see that even the population is increasing about only 16%. The water need is increasing by more than 4 times, I mean 55%. So this is we can't reduce this the evolution of population, of course. So we have to get in mind that the population will increase. That means we need more food, more jobs, and we will get more pollution of the environment too. So this is, we have to get this in mind. In another from another point of view, you know that more than 55% of water resource in Tunisia are coming from dams. And the most important dam in Tunisia is Sidi Salim Dam, which is the heart of the hydraulic infrastructure in Tunisia. But we have in the extreme north of Tunisia another big dam which called Sidi al-Baraq Dam. And this dam was built near the sea. It means that the discharge of this dam is in the sea. And that means also that to use this water, we have to pump it for long distance, because there is a connection in the north, north between dams. But for many years, we didn't use this dam because it's very far from the place where we need water, and the pumping to pump this water we need a lot of energy, and so the cost of this water is very high. So for more than 16 years we didn't use this dam, and we use only Sidi Salim Dam. If you look to this picture, also we can see that from 2001 to 2017 we lost in the sea more than 240 million of cubic meter a year discharged in the sea. That means that in case of what we can call floods, of course a lot of water that come, we can't transfer water, of course, from this dam to the other dams, because all other dams will be full. So we will get all water will go to the sea. So we have to think how to use this water in case of drought, especially when we know that there is not only this dam in the north, we have 6 other small dams in the extreme north that we are not using now because of the transfer of water and the need of energy. So this is just to have an idea about Tunisia. You have the Sidi al-Baraq Dam is in extreme north. You can see it in the top on your left. And we have to know that more than the 2/3 of the population and the activity are at the coastal area, and all our dams are in the north. That means that all our surface water and renewable water is in the north. There is no water in the center like in Sousse, Kairouan, Sfax, Gabes, etc. And actually we transfer water from the extreme north via, of course, inland pipes to the center, to the Sahel, what we call the Sahel. And this option is not sustainable, because in case we don't have water in dams, this transfer is not possible. So my idea is how to transfer, to put in place a system of a huge quantity of water, because we need a lot of water. Why I am thinking of this possibility or this idea, my main concern is agriculture, because you know, in any country, in case of drought, the water supply is a priority. But the experience in Tunisia shows that we can't secure water supply when you don't secure the water for irrigation and for agriculture. And in case of drought, we need water not only for irrigated area, but for all agriculture area, especially for rain-fed agriculture, because more than 2/3 of the agriculture GDP is coming from rain-fed agriculture. So we have to produce a new water, if I can say, with a little cost, because we can't sell this water for farmers if the cost is very high. So is it possible, or can we work together or improve this idea to transfer water by the sea using flexible water pipes, which call it Submariver. Submariver is the company that have produced this technology, and we can have more information about this new system, innovative system, via the website of Via Marina, as you see in the screen. So what is the advantage of this idea? Is to supply the coastal city that this will reduce the pressure on the ground infrastructure transfer from inland. We reduce the water evaporation, because we have to get in mind that in the future we will have an intensification of the water cycle. It means more evaporation, more evapotranspiration, more runoff. So water don't have enough time to go in depth in the soil, so to improve infiltration. So we can use this technology, this new technology, we will win more than 10% of water that will go over evaporation. And we can evaluate with this idea the water resource during extreme events, and we will not speak about floods, but we will speak about the opportunity of this huge amount of water. So how we can do? We have to take water from the mouth of the river before getting in the sea, and you transfer this water via a flexible pipe underwater, of course, in the sea at more than between 100 and 200 meters in the sea. We can use this also in case of we have the discharge of wastewater in the coastal city, so we can also transfer the treated wastewater that are discharged in the sea also. This is an idea of what is this pipe. We can use a very large diameter, up to 4 meters, flexible and collapsible. And what is important to know here, that of course we will try to transfer water from the level 0 to the level 0. Okay, so we don't need a lot of energy, first of all. Second thing, that we have to deliver each 150 kilometers or 200 kilometers, you have to deliver water. So we have another pumping station. This means that you can use the pipe in the 2 directions. Here you have an idea about the propriety of the system. It's very easy to the installation of the unrolling pipes, and as I'm saying, so we can put these pipes at something like 200 meters in the depths of the sea. It's of course a proven technique. We use this in the transfer of gas and oil, actually. So it's not a new technology, but the technology is how to use it for water. So it's an ecologically sustainable opportunity. We will take water from the mouth of the catchment, so we will take only a fraction of this flow. Thinking about ecological demand, of course, because the sea need fresh water also. If we use this technology, we will reduce the marine pollution. We can use this water, of course, transferred water, for the recharge aquifers and dams. There is no earth movement. It's an ecological niche for biodiversity. There is a limited energy of consumption energy, and there is no waste and no chemicals to use. This is very important. As I say, if we link the water availability with food security and energy, it allows a GDP growth, industry, tourism, agriculture. It's a supplementary fiscal revenue, job creation, exportation. Since in Tunisia, we export more than 50% of our exportation is coming from olive oil, and which is very vulnerable to climate change, of course. This method will allow a life level increase and a life quality improvement also. As I said, it's technically viable because this technique is well known. We use it for offshore, for oil and gas. This technology have been performed using spending more than 10 million of euro. We have done different feasibility projects. It's simple and robust. A high qualified workforce, it's not required, and its flexibility. It's the more important advantage is the flexibility, anti-seismic, and if there is a collapse or a rupture, there is a fresh water going to the sea, so there is no problem for that, and no pollution at all. About cost, it's a limited cost. We can transfer a large quantity of water. It's not like what we have actually with conventional transfer, with the pipe and with the pumping station using a lot of energy. This need for the construction, we don't need a lot of time. We can put till something like 8 kilometers per day. It's an infrastructure for a very long term. We don't have to move population or to protect this pipe from any risk, etc., and any illegal use, if I can say, because now in case of drought, farmers use also potable water for irrigation, so they reduce availability of water for consumption. This is in the sea. Nobody can go and use this water, and we have a capex of about 70%, 30% OPEX, which is different from desalination, where this is the capex is about 30% and OPEX is 70%. So the cost is more certain in this case. So as I mentioned in this figure, the transfer vision is to take water at the mouth of the river at Sidi al-Barraq before going to the sea, of course, and you put a very long pipe and you deliver water each 200 kilometers in the important cities that need water. The second idea is we have to build, from my opinion, of course, we have to build this solution of this transfer access, because actually we are building 4 new desalination plant. The first seawater desalination plant is in Jerba now. It start working in 2018, but we are 4 other stations, one in Gabes, one in Sfax, one in Sousse, and one in Mahdia are under construction now. So this system can allow the transfer of water from one region to another. And we can use this system to deliver water in the main cities where there is no water for irrigation. In Sousse, in Mahdia, near Sousse, Monastir, and Sfax, water is coming from the north. And if there is no water, we can't secure anything in irrigation and in water supply. So the idea is to build this new transfer axis using flexible pipes, and using, even we can, if there is a problem of energy, we can use renewable energy for this vision. We try to elaborate a pre-feasibility study with this company, Via Marina company, and we find that it's possible to transfer something like 10 cubic meter per second, something like 300 million of cubic meter per year from Sidi El Barrak Dam to the north of Tunisia on approximately 200 kilometers, with a full cost of 0.26 euro per cubic meter and an energy consumption of 0.2 kilowatt per hour per cubic meter. So this is 20 times less than the seawater desalination, and of course, the cost of the investment is very high. It depends if you can put in place this project for 200 kilometers or for 600 kilometers. It depends on the choice of the government, of course, the Ministry of Agriculture in Tunisia. But we have to get in mind that this is another opportunity to evaluate the excess of water in case of extreme events, and to create a new storage strategic area to storage water, especially for irrigation use, because it's impossible actually to use desalinated water for irrigation. The cost is very high, and it's impossible to secure water supply if you can't secure water for agriculture, because agriculture is related to food security and even security in general, because we have seen in these last 2 years the situation was really very bad, and the government don't have any solution to bring water for agriculture sector. They say there is no water and we have to pray to get water, and this is not, of course we have to pray to get more water, but I'm afraid that in the future there is a huge intensification of extreme events. So we will see drought, or we will see floods, and we will not have average situation, I mean. So we have to make planification having that in mind, and to try to see to make more to go in depth with this opportunity, and to see how we can put in place this new technology with transferring water at the end of the catchment when it's discharged in the sea, and to transfer it to coastal area, like this case in Tunisia. So I'm dreaming maybe because Roman people have transferred water via aqueduct from Zagouan to the Carthage, and maybe we can build a new technology like Roman aqueduct, but via the sea, and with the idea to secure or to reduce the water stress, maybe not to secure, because it's an option with the desalination. We can't forget that, but this is an opportunity to reduce the water stress in Tunisia, because the situation is coming worse and worse. Thank you very much.
Thank you very much for your lovely presentation, Professor GAFREJ. I want to ask the participants, anyone, do you have questions to Professor GAFREJ? I guess we don't have any questions at this moment, Professor. Thank you very much for your lovely presentation.
Thank you.
Now I would like to invite Professor Dr. BARIŞ SALIHOİLU to deliver his presentation. Professor SALIHOİLU?
Yes, I'm here. I'm starting my presentation. Can you see it? Can you hear me?
We can hear you, Professor, but currently, yes, we can see your presentation as well.
You can see my presentation. Okay. I would like to thank the organizers, Near East University and Professor Gökçekuş for the kind invitation to this great organization, great panel. And today I would like to talk about how climate change affects the marine environment and how climate-related strategies are taking place in the region. And Professor Karaca has already given an introduction on the global effects and regional effects of climate change, so I will not go over them again. But here, what I would like to briefly show is that after 1980s, what you see on the right-hand side bottom is that land surface is heating up more than the ocean surface, but when it comes to overall heat absorption, oceans absorb over 90% of the excess heat. So ocean's role in the overall heat cycle is much greater than the land. And this was shown at the beginning, and when it comes to our region, the Mediterranean basin has already increased by 1.4 degrees, and this is more than 0.4 degrees of the global average, and the sea level has risen by 6 centimeters, and ocean acidity is increasing. And our region is one of the regions where the climate change is affecting the most, the Mediterranean basin. And when it comes how this is affecting the sea basin, is that the waters are increasing. You can still hear me, right? Because I can't hear any background noise at the moment. I'm not. I think everything is okay. Okay. And so the waters has, the sea waters has increased also 0.4 above the average. As Professor Karaca has shown, the average ocean seawater has risen by 1 degree, and in the Mediterranean, this was 0.4 more than the average. So about 1.5 degrees in the Mediterranean waters, although it varies between the regions. And the
everything is fine, you can continue, Professor.
Everything's fine, okay, thank you.
We can hear you, and we can see the presentation.
Thank you, thank you. And when it comes to rainfall, especially in the Mediterranean coastal area, this will decrease, and even some of the lakes may dry up by 2040s. When it comes to the Black Sea region of Turkey, there may be some increase in the precipitation, but in the Mediterranean coastal areas, definitely it's going to decrease according to the global models. And the Mediterranean is more and more becoming more tropical, and we all feel this. There are many non-native species in the Mediterranean already, and with the increasing temperatures, these will even increase more. And apart from the climate stress, there will be more invasive species stress on the Mediterranean ecology. And one of the main ramifications of climate change is the acidification of the oceans. And the Mediterranean is also part of this. And as you can see here on the right-hand side, as the atmospheric CO2 increases, the pH decreases, and as a result, some of the calcareous species in the Mediterranean are losing their shells, and this is negatively impacting these creatures in the Mediterranean. And when it comes to the Black Sea, there the increase in the Black Sea surface waters, the increase in temperature is even more than the Mediterranean. You can see the evolution. This is the data that we have been collecting over the last 6 decades, and you can see how the surface waters of the Black Sea is heating up. And this has even more dramatic effects on the water masses of the Black Sea and its circulation system. The so-called cold intermediate layer of the Black Sea is disappearing over time. As the waters heat up, the different water masses are changing, and this is also affecting its circulation. So what happens when climate affects the marine system? Then the services that we get from the marine system, the ecosystem services, are also being affected. And these services that benefit from the marine ecosystem can be categorized under 3. These are the provisioning services. These are mainly food and biotic raw materials. And regulating services, these are mainly climate regulation, clean air, regulation of water, waste processing, coastal erosion, and biological control, and cultural services, recreation, cultural heritage, tourism, cultural diversity, and information. So we need to both protect the marine ecosystem, as well as we need to deliver solutions so we benefit from the marine ecosystem services in a sustainable manner. To do so, we need strategies. We need different strategies, and I would like to go over the different strategies in the marine area. And for all the ocean basins, there are different research and innovation strategies in the Atlantic, in the Baltic, in the Mediterranean, and in the Black Sea. And we have contributed to the Mediterranean strategic research and innovation agenda, and we have led the efforts of developing the Black Sea strategic research and innovation agenda. And when you look at these strategic documents, there you see that climate is one of the priorities. For example, for the Mediterranean, one of the priorities defined for the Mediterranean tells us that we need to develop services in the field of sustainable adaptation to climate change. And we need to develop plans for mitigation towards climate change as well. And the goals that we need to meet is to better understand and forecast the Mediterranean sea dynamics, be prepared to climate change, and understand and deliver user-friendly tools for sustainable climate services from the Mediterranean. And in terms of blue growth priorities, climate change is one of the challenges that needs to be addressed, together with better understanding the marine ecosystems, the cultural heritage, developing observing systems, and combining data, green transportation, the planning of the Mediterranean, offshore platforms, especially combined platforms, and sustainable tourism, sustainable aquaculture, fisheries, and biotech are the other priorities that are defined for the Mediterranean. And when we look at the Atlantic Ocean, it's also highly affected by the climate change, but the priority defined there is to better understand the uncertainty and change, because there are a lot of uncertainties when it comes to forecasting, and we need to better understand how these marine systems will change. And in the Baltic, which is also an enclosed basin, enhancing sustainable use of coastal and marine goods and services under different stressors, including the climate stressor, is the priority there. And when it comes to Mediterranean, what we did, we have developed an agenda that builds on 4 main pillars. And the first pillar is on knowledge bridge, better understanding the research challenges in the Black Sea. The second one is on blue economy. The third one is key infrastructures. And the fourth one is on people, empowering citizens, and on education and capacity building. And Black Sea is affected by many stressors, including the climate. So understanding the combined effect of these stressors, and also differentiating the effect of climate is one of the priorities here. And also the climate effects would bring some coastal hazards like erosion, landslides, sea level rise, extreme events. Also understanding this and delivering some risk assessment strategies are the other priorities for the Black Sea Basin. And as you all know, UN has established sustainable development goals that all the countries has signed to address. And one of the targets, one of 17 sustainable development goals, is directly on climate action. And some examples of the targets of this action is strengthening resilience and adaptive capacity to climate change, integrating climate change measures into policies and planning, and building knowledge to meet the challenges of climate change. And another European strategy is Green Deal, and achieving climate neutrality is one of the main targets here. The Green Deal aims a climate and energy package and launched it on 2020, and on 2030 climate and energy framework will be established, and meeting climate neutrality by 2050 is the long-term strategy here, and this is recommended under the climate law as well. In terms of the oceans, one of the main programs is Mission Starfish. This is taking part under Horizon Europe, and most of the funding that addresses the effect of climate on the oceans will be under this mission ocean, and decarbonizing our ocean seas and waters will be one of the pillars of the mission oceans. And there are some goals under this, for example, transport by climate neutral waterways, supporting the energy transition through renewable low-impact ocean energy. It's obvious that oceans will play a critical role in terms of clean energy. Zero carbon aquaculture. Aquaculture is promising, but it needs to be also climate neutral. And one of the emerging fields is blue biotechnology and blue tourism. And also in the Mediterranean region, we definitely need to consider this. And we are leading a new project called Bridge Black Sea. And we have designed, this is a 9 million euro Horizon 2020 project. And here we are tackling the challenges related to the Black Sea. And what we are looking at is that there are many stressors that affect the marine system. And climate is not the only one. Warming is not the only one. For example, for the Black Sea, there's deoxygenation, acidification, overfishing, invasive species, eutrophication, pollution, and different sectors' activities. This is similar for the Mediterranean as well, maybe other than the deoxygenation. And these affect the ecosystem services that these seas provide to us. And to meet these challenges, we propose that we understand the resilience of the ecosystems and how these are affected by these stressors. And based on this assessment, we need to develop new innovative ways to protect the resilience and the biodiversity of these ecosystems. And while doing so, we need to include the society. We need to include the society both in terms of supporting the science, but also by educating them. And we need to develop solutions that the policymakers will benefit. And this is how we have established this project to tackle these challenges. And the very recent development in Turkey is that Ministry of Environment and Urbanization has modified, and now it's Ministry of Environment, Urbanization and Climate Change. So now we include a department on climate change and adaptation, and they are at the moment developing their strategies towards meeting the effects of climate change in the area. So very briefly, I wanted to summarize how climate is affecting the region and which regional strategies are there to address these issues. Thank you.
Thank you very much, Professor Dr. BARIŞ SALIHOğlu, for your valuable speech and presentation.
Thank you.
In this session, we have hosted very valuable scientists, Professor Dr. Mehmet Karaca, Professor Dr. RAOUDHA GAFREJ, and Professor Dr. BARIŞ SALIHOğlu. Thank you very much for your contributions to NRSEM 2021. And now I would like to take, if our participants, they have questions for you, Professor SALIHOğlu, Professor Karaca, or Professor GAFREJ. Okay, I guess we don't have any questions. So thank you very much to all of the professors who have contributed in this session. And thank you very much for your valuable contributions.